Okay, so we're not given anything as congruent. We're given parallel lines. Okay, and you guys had one of these on that book assignment, and you had one in your proof homework in the packet. So when you see parallel lines, if you write your first given down, PQ is parallel to RS given. Now, just like that last chapter test, if I give you parallel lines, what is the automatic next reason in a proof? If parallel lines. Don't get away from that. Okay, if I give you parallel, just like that last unit test, you should say if parallel lines for statement or reason 2. Because otherwise, what's the point of me giving it to you? If parallel lines, then. Well, what usually comes true? Something is what? Congruent. You should automatically know that stuff right there. You probably can guess what number 3 and 4 is. The other given, and then the if parallel lines then. Okay? But let's just wait on that. Alright, so let's first just look at PQ being parallel to RS. If I would just highlight what I just said was parallel. Parallel does not mean congruent. We need to make sure we get that out of our head. That just simply means that those two lines that I highlighted in yellow go on forever, never crossing. Do you see a transversal that connects those two yellow lines? Yeah, you should see QS. Now, if I just think about that as the last unit, you should see some type of angles that are now congruent by those yellow lines. Do you see them? Do you see a pair of angles that touch just the yellow lines? Like this angle here only touches one yellow line, right? We need to touch one yellow line and the transversal at the same time. So up here, does this touch both yellows? No, it's this guy here. This angle is going to be congruent to this angle. What type of angles are those on those yellow lines? They're alternate interior. So if parallel lines, then alternate interior angles are congruent. Now, the hard part for some people is the naming. Which angles were congruent that we just marked? Right, and some people are going to say Q and S. Well, yeah, I can see that it's Q, but if I just said on this problem angle Q is congruent to angle S, you'd say this Q or the giant Q. So we have to be more specific. Q has to be in the middle. So PQS, make sure you put an angle symbol out in front. Angle PQS is congruent to angle, and make sure S is in the front, or in the middle, I mean. RSQ maybe. Why? Because if parallel lines, then alternate interior angles are congruent. You should now automatically know what the next two steps are going to look like. Why? Because I give you another set of parallel lines given. So QR is parallel, to PS. Whoops, that is given. You should now, again, if I give you parallel lines here, then you should automatically know over here it's going to be if parallel lines then. So we're now going to trace the other parallel lines. Again, if you have a highlighter and you think this is helpful, do it. I don't care. If you need to borrow a highlighter, feel free. So now what's parallel? QR, so this blue line with PS. Do you see a transversal that connects them? Well, technically there's 3, right? All 3 yellow lines connect them, but only one yellow line up there really works, and one that we want. Which line's my transversal in this case? Which line would I want for my transversal? QP, QS, or RS? QS. So if I just look at my blue lines, do you see a pair of angles that are congruent because of those blue lines in the top, bottom being parallel? You should see that this angle touches the blue line in a transversal, And this angle touches the blue line in a transversal. What are those red tick marked angles? So we have parallel lines, then alternate interior angles are congruent. Which angles are them? Make sure you write them carefully. Angle PSQ would work for the one on the bottom. And what's the one on the top? SQR. Now, you could have done this proof that's now 4 steps long. You could have done it just in 2 steps, couldn't you really?
Yeah.
You could have put both parallels as your first given, and then you could have said this, comma, this, if parallel lines and alternate interior angles are congruent. That is possible, but you don't have to. It's up to you. Now, let's look at our picture. Our picture shows 2 pairs of angles congruent. I'm out of givens. We have the reflexive property. Which pair is reflexive? So we say QS is congruent to QS by reflexive property. And so now I can mark that on my picture that this side is congruent to itself. And so now are these triangles congruent? By angle, side, angle. Okay. Making sense. It's using everything, and this is what I was telling parents about at parent-teacher conferences. This is hard for some students because look at what this just did. It took a knowledge reflexive property that I taught you probably the 3rd week of school. It used very extensive stuff from our parallel lines unit, and now it's giving us stuff from the very beginning of this unit on how to prove triangles congruent, and it's making you look at a picture and decide what do I have, and then going from our memory bank and grabbing what I need. So no, this isn't Algebra 1 where you do a problem and you do the same one 10 more times. It's geometry where I teach you a bunch of stuff and then now we apply when we need it. Okay? So it is a tougher class because of that for some students. Alright, let's take a look at the next one. We have midpoint. C is the midpoint. Well, if you thought, oh, what does that mean again? Well, we did a very easy midpoint, I think, on problem 1 or 2. In our flip chart. Maybe it was 3. But either way, it's up there somewhere. So, start with the first given. It's always somewhere to start with. C is the midpoint of AD. What's usually always followed that? What reason? Definition of midpoint. Tell me what midpoint means right now. Midpoint means it does what to a segment? Into 2. So there you go. You know there's going to be a congruent symbol there. Now you got to go to your picture. If C is the midpoint of A to D, use the picture. If C is the middle of AD, what is now true because of midpoint? There you go. So there we go. We have I give you a given of midpoint, we used it. Move on to the next given. AB is parallel to CE. Oh, this looks familiar. No matter what will we start number 4 as? Parallel lines, then, and we don't know. Maybe it's alternate exterior, maybe it's alternate interior, maybe it's corresponding. I doubt it's same side interior angles are supplementary because we can't prove triangles are congruent by supplementary stuff. Okay? So now we're going to trace our parallels if you want. We just said that AB and CE are parallel. There's AB There's CE. Now, do we see a transversal? BC is probably one that our eyes hit first, but watch. If I trace, I'm just going to do this. If my red pen represents my transversal, do you see a pair of angles that are congruent? I mean, I see a pair. I see this pair here, this one with this one. But what do you notice about that angle? It's not in my triangle, right? Yeah, we could say it on our proof, but it doesn't help us prove that my two triangles are congruent. So now let's think, is there any other angles that are congruent with that transversal? So let's pick a different transversal. Where's it? AD. If I trace this as my transversal, what do you see coming true now? Do you see a pair of angles that are congruent? Which pair? Or what type? Let's do what type. Alternate interior are corresponding. Are you thinking this one and this one? Yeah. Now, if parallel lines, then what'd you say those were? Corresponding angles are congruent. That's half the battle, just saying that. Now name them. Where are those angles at? I could truthfully call this just what? That's fine. I could call this just angle A. Now, if you, I'll finish what I'm saying in just a second. What's this angle here called then? Angle C, right? I cannot call this angle C. Why? I got 1, 2, 3, 4, 5, 6. There's 6 different angles at C. This little one, this little one, this little one, these two together, the big one. I can't call it angle C, so be more specific. ECD. Now, some people look at that and their mind doesn't like that. I got 1 and 3, they don't match, right? OCD issues or whatever. So feel free to call this angle what? BAC if you'd rather. So if it bothers you that you have a 1 and a 3, make that 3 letters. BAC is fine. But now I got tick marks in my picture. We're getting somewhere. I got a pair of sides congruent because of the definition of midpoint. I got a pair of angles congruent because of parallel lines and corresponding angles congruent. I still have another given. BC is parallel to ED. Color them with a different color if you wish. These two lines now are parallel. Do you see a transversal that's helpful? Well, there's 2. There's EC that connects the 2 blue lines, and there's AD that connects the 2 lines. Which one's most helpful? AD. So I'm going to trace it just because that way I can visually see it. And everything I'm doing with the highlighter now, guys, is optional. You don't have to do this. It just helps you see it. Do you see a pair of angles that are created that are now congruent by my blue lines? Do you see them? What type of angles are they? Corresponding again. It's basically the exact opposite we just did. These two, here and here, touch the blue lines in a transversal, and they're corresponding. So if parallel lines, then again corresponding angles are congruent. We're now going to name them. Angle BCA and angle, how would I name this one? I could just say D. I could also say EDC if I wanted. Okay, this is the longest proof you've seen. Can we now declare my triangles are congruent? By ASA. Which triangles? Just look back up at the proof, it tells you. Questions? Okay. Let's take a look at, we have 2 more proofs. You should be able to get a good start on this proof. If anything, you should be able to finish this one. Go ahead and get it started. Like I said, you should be able to run with this and know what to do. The things I just wrote on the board, or on this foldable, is things that you should automatically know. Like, you shouldn't have to right now look at the board and say, oh yeah. Like, if I give you midpoint, you're gonna use definition of midpoint. If I give you parallel, you're gonna say if parallel lines. Do you have to do it in this order? No, you could do given, and then talk about midpoint and parallel lines. It just doesn't make as logical sense to me, but it's not wrong. Put these in your folder. These are homework. I just want to pass it out now. All right, if C is the midpoint of AE, what did you write was congruent? AC to CE. Now, so many students on tests and quizzes will give me the wrong pair. They'll look at this picture and just pick a pair that they look congruent. But it clearly says that C is the midpoint of AE, so only look at AE, and so therefore that's how you get the AC and CE. Okay, so now I got my parallel lines. Which pair? AB is parallel to ED. We have a couple different options for my transversal. Now, the only thing is that I want you to prove angle, angle, side on this and not ASA. Because this is on a flip chart, right? Now, if this was a total blank problem on your homework or your test or quiz, you could go whatever route you want. Let's pause for a second. After I mark whatever I'm going to mark, what's another thing I'm going to talk about? Vertical angles. If 2 angles are vertical, then they are congruent. Where are they at? Well, it's where the X occurs. Do I want the left and right or top and bottom ones congruent by vertical angles? The top and bottom ones aren't even in the triangles. So don't do them, do these two. What are those angles? Those angles are angles BCA and angle what? ECD. Now, why did I skip to this? Because like I said, since we're on the flip chart of AAS, then you need to think, with my vertical angles, where is my A need to be at? For AAS, this would make it ASA, right? And like I said, this would be fine on a homework. If I didn't say end it by AAS, you could do angle A and angle E, And then those triangles are congruent by ASA. But since this is in the flip chart for AAS, let's say that this angle up here is congruent to this angle down here, because here's my transversal, and those are alternate interior. And so, can I just call it angle B? Is that safe? Yeah, it's only angle at B. It's the only angle at D, so it's safe just to do that shortcut. And then now we can see that these two triangles are congruent by AAS. Questions on that one? All right, let's do the last one. We have TV bisects SVU. We already can predict that this is going to say what? Definition of bisect. I can already predict that this is going to be a given here. And I'm going to state my other given. Oops, sorry guys, you can't see it. All right. If I bisect something, what happens? Cut into two equal pieces. What am I cutting? An angle. I'm going to get two angles. Where's my vertex that I'm cutting? V. So guess what? V's in the middle of these two. So look at the picture. Where is angle V at? We're cutting angle SVU. This angle is going to get cut in half. Where's my two baby angles at V? Here and here. So name them. Angle SVT, and angle TVU, or UVT, it doesn't matter. We just wrote down my other given, but we didn't mark it. Angle TSV, so S is the vertex, so S is where the tick mark goes. And then TUV, U's in the middle, so U is where the tick mark goes. All right, I got two angles congruent to two other angles. Where's my third markings going to be at? Reflexive. What is the reflexive statement? TV. I can go to my picture now and mark it. This side is congruent to itself. So are my triangles congruent? Angle, side.